Hey everybody, thanks for joining us on this cold, frigid Wednesday here in the southeast. Hopefully everybody's be able to get out of the office before we have the snowpocalypse again. But thanks for joining us. We have a really special presentation we wanted to bring to our customers. At this past AU out in Las Vegas, one of the biggest things, and I'm sure for the folks on the call that were out there as well, one of the biggest things we heard people talking about was Dynamo. So in case for those who are not familiar, Dynamo is basically an open source tool that allows Revit to do computational design. And so it's included in Revit today, so we thought the best thing would be to get some experts in here to kind of explain what it is and how you can start using it at a high level with our webinar today. So we brought in two folks, Matt Jezik and Colin McCrone with Autodesk. Matt is actually the Autodesk Senior Product Manager of AEC Conceptual Design, and he's going to be leading the presentation along with Colin, who's the Dynamo Evangelist. And so we're really excited with that. And so with that introduction, I just want to pass it right over to Matt.
Hey, thanks a lot. Yeah, this is Matt Jezik. Thanks for having us in today. We have a team inside of Autodesk that's been working on this Dynamo project. A lot of us are architects and engineers and came from working on things like Revit, both out in the industry and developing it inside of Autodesk. So happy to talk about what we're doing with Dynamo and how you can use that to essentially customize, your building information model and work more effectively with other people inside of your company and with your colleagues in different firms. So we're going to talk a little bit about computational design and kind of this space that we see evolving similar to building information modeling. But it's kind of been separate for a while. It's been the province of other people that might not be using BIM or Revit now. They might be using other tools, geometry modeling tools or programming tools to do types of work. But we've been seeing a lot of emphasis on that. You see a lot of kids coming out of school that learn various other applications. And what we're going to do is just talk about how they're using that and how we see them coming together, where computational design and BIM are coming to be the same thing, essentially. You're going to build one building at the end of the day. So it makes sense to have essentially your early design process tied pretty closely to your project delivery process and have that be a tight iterative loop. So just a quick case study. This is a project in New York City. It's a post 9/11. This is a transit center about 2 blocks away from the World Trade Center. It's called the Fulton Street Transit Station. And this is a Grimshaw Architects that did this work. This is actually a big light reflector assembly inside of this big, block wide, essentially subway station. And what they wanted to do is build, if you can see my mouse on the screen, they wanted to create a skylight that could reflect light all the way down to, about 120 feet down into the subfloor. So they created this big interior structure and then a big reflector kind of system, like metal panel that was like pretty tight tolerances from fabrication standpoint. And it followed a certain set of rules. So what they did is created this stuff with literally a setting out drawing that says, okay, here's the geometric rules to follow. And instead of just building one geometric model that would need to be changed manually every single time there was a design change, and as like every other project, there's lots of changes happening, what they did is they built a system. They built essentially a small little computer program using this visual programming techniques that we'll talk about to handle, how to lay out the geometry, how to slice it up by different levels, how to build the superstructure that's all tube steel, and how to build this interior hanging cable net that supports these, essentially shiny metal panels that are going to reflect the light. And it was really effective for them because they could not only from a design standpoint handle that, but carry that information all the way through the construction process and into fabrication. So the guys that actually did a lot of the fabrication work for this, this company called Enclose, were able to take that exact same information and in many ways the exact same graph, that computational design idea and carry it through to start driving their machines and check to see if they've built the right thing. So that's what we're talking about with what computational design is. And in many ways, I mean, it's not that different from, you know, all the way back in the Renaissance when people were drawing and setting out, okay, here are the rules that we're using to make a building, or even back before then. All we're doing is just using more advanced computer techniques to capture those rules and enforce them. And other guys, like, you know, another Grimshaw project from about 20-some years ago, Waterloo Station over in the UK, pretty similar idea, right? So it's like you have these big trusses, and the site changes in its width, so the trusses need to change their span, but the rules used to create them aren't any different. They just change their length. So that's similar to how things like Revit work already, where it's a parametric system. You know, you don't have to redraw all those trusses. You build one family and have it, you know, change itself. What this does is it lets you handle bigger changes than even just what Revit can handle, and that's what we'll be talking about a little bit more here too. So, and that's what we're talking about with this idea of computational BIM. Here's another project, and in fact, this is another transit station. This is over in LA. HOK project, and Burrow Happel was the engineer on it. Really great example. A lot of good write-ups on this online, but this is a full BIM, 100%. Every single trade, every single you know, consultant was using a BIM model and a full BIM process here. But it wasn't just about making, you know, the Revit drawings or anything else. It was about capturing, excuse me, the design ideas in a way that can handle change, and that's what they were able to use computational design ideas for as well. So combining that with using BIM to create the detailed drawings and work with, you know, the various engineers and contractors, they were able to have, you know, some sophisticated programs that could handle where these intersections are, how the geometry works out, and pull that information out, not just to use it for creating drawings, but to do analysis with it as well. So combining the geometry, extracting that out to do things like daylight analysis or do things like computational fluid dynamics to figure out airflow, all of that was more possible because these things were not, the model was not just being used to create essentially, you know, 1,000 drawings in a drawing set, but it was able to carry all the way through into construction. That's another key thing, where you can handle these design changes effectively, understand the impact of them on cost, on schedule, on the performance of the building more effectively, because you literally have a better view into what's happening through using these computational tools. So anyway, so what's Dynamo? So as was mentioned before, Dynamo is essentially a visual programming environment that lets you supercharge something like Revit, where if you think about it in terms of what Revit's good for, so, you know, I'm an architect by background. I was one of the original guys working on Revit software development and design, and we inside of Autodesk have spent a lot of time making things like curtain wall or, you know, ducts and pipes and structure work, and we've built in a lot of rules into the system, but we can't think about every single rule or support every single rule that comes up in, you know, every project around the world. So what we have now in Dynamo is a way for you to customize the types of rules you need to support a project and do it in a way that doesn't require you to be a math genius or, you know, a computer science guy. You can basically use this visual programming environment to start connecting these nodes together that represent, you know, objects like a wall, and pull out information from them and put it somewhere else. So like literally, you know, we've heard it say like, well, if you can connect pieces of your stereo equipment or your DVD to your TV, that's kind of the same thing, where you just plug in wires from one thing to the other and the information just kind of flows through. So that's the best way to think about what visual programming is and what we were talking about with computational BIM. It's a way to add other rules on top of Revit. And those rules can be geometric, you know, just simply laying out things like, you know, curvy splines, say, for example. But it also has to do with applying other rules here, where in this case, there's a set of operations, say, you know, if the curvature of this is too much, break it up into smaller pieces. So you can add additional steps and conditional logic to these things that make sense to build up a structure. And we'll talk about that a little bit more. once you have these things, because you're designing a system, you can change that really quickly. So you can do options, you can look at variations really easily. In this case, this is like a facade screen, just looking at different perforations in like a metal panel, say for example. You can run through that simply by changing a slider or some input and not have to worry about remodeling anything. And it's a lot more flexible than simply building up a parametric object in Revit, because you can change things at a higher order, and Revit's not going to yell at you. It's not going to fail because something isn't there. It just is simply getting rebuilt from scratch. And that is useful all the way through into fabrication as well. So here we see this is Dynamo, essentially running as an add-on, and there's a representation of this model, and then you have a more detailed representation in something like Revit or other applications. So the basic idea is that Revit's being used for more than just creating drawings. You're building up these parametric rigs. You're kind of getting the best of both worlds. You can use families and sort of these parametric behaviors that are built into Revit, but then you're using Dynamo to control the top-level inputs to that, what the dimensions are, all that kind of stuff. Kind of like a puppet master. You're controlling a bigger thing, and then letting Revit do the rest of the work by figuring out how that family should look and behave and update. Same thing with things like analysis, where Autodesk, we've been in the analysis business now for about 5 or 6 years, especially in the AEC industry, the building industry, acquiring different companies like Ecotect, Square One, and also Green Building Studio. And we've been actively incorporating them into our applications like Revit. But one thing we've heard people do is say, look, I don't just want to make pretty pictures. I don't just want to see the results of some analysis, like in this case, solar analysis on the outside of the building. I want to use that information to make a better decision, or to have my model update, to add, in this case, like louvers or some kind of fin assembly to start handling things like the excess amount of energy coming in. And that's what you can start doing with Dynamo, where it's not just about looking at the results, it's about incorporating those results and changing your model from there. So that's what we see people doing. So we see a lot of work with customers using Dynamo now. A lot of high-end architects and engineers all around the world are using this, and a lot of other firms as well that might not be doing as much curvy geometry are using it as well. So just one quick example of using it for architecture, also for things like bridges. We've seen a lot of interest in using Dynamo for connecting the dots between different applications. So in this case, this is actually a construction company in Mexico that is working with us, and they come to us and say, hey, look, this is our process. Like, we're using a lot of Autodesk tools, and we're a big design build company, so we self-perform a lot of work. These are the things on the right that we want to create, and these are the things on the left that we're using to create them. We need a better way to connect the dots. So this is actually not a very sexy problem. It's in fact just simply moving information from one source to the other to make things that look like this, which is basically a precast concrete highway overpass, kind of a raised elevated road. So this isn't like doesn't just have to use Dynamo to create the next stadium from Zaha Hadid or something like that. You can use it to create and make things more efficient that are part of your daily process. So let's run a quick video here. The basic idea here is that they're working with a civil engineer that's creating essentially a centerline position, and they're reading that center line and the points along it to start creating a raised roadway without having to manually place all of the columns and foundation members and then the superstructure. They're able to use Dynamo to instantiate all of that. So these are all smart families that are directly tied to this company's fabrication process, where these are all, think about it like a precast module, like a T that is going to be formed in a shop. There are going to be certain modules that are the same size and certain ones that are different, and those are all itemized and sort of quantified using Revit and then taken out directly to fabrication by extracting that information from Dynamo. So Dynamo is used to create the stuff from the center line from the civil engineer, and then is used to take it to the next level for creation of the actual modules in a factory. So that's, again, like not just conceptual design kind of workflows. This is all the way through and making things more efficient throughout the overall process. And we see that a lot. There's another example, kind of more architecture related, where if this is a tower design of some sort, a lot of what we see big customers doing is saying, look, here's my design for the tower. I might have created that in a surface modeling tool of some sort, and I started chopping it up to figure out what levels there are or where the curtain wall panels are going to be, and I need to create a detailed model in Revit from that. So you have essentially a list of points. So these blue dots right here are a list of, say, 1,000 points that all need to get connected up and made into curtain panels and then applied to different types and that kind of thing. That's all handled from Dynamo, and basically the software takes care of all the bookkeeping for you so you can focus on design. And design at the top level, changing the shape of the building or the design of structural system or how the building's really going to work from an enclosure standpoint along the way. And then literally the connective tissue becomes something that's a graph that you control. And that's the same thing I was talking about before, where it's not about Autodesk having a magic export to Excel button or something. It's about you being able to say, look, I need to dump this information out to Excel or to various other applications out there, and you have the ability to control the format for that. Here's another quick example. This is a great case of architects and engineers working together. So this is a doubly curved surface. Oops, and sorry about the soundtrack here. So I can turn that off. The basic idea is that the engineer and the architect are working together to create essentially a space frame truss around this doubly curved surface, and they're going through different design ideas. They need to look at that aesthetically, what it's going to look like from an architecture standpoint, and then also how it's going to perform from a structural standpoint. So one of the problems we have in Revit is that you can make something look, very detailed and well connected, work on the fittings and connections there, using things like adaptive components to make it look like welded tube steel, or you can make something that is of structural objects that are tightly connected and know what they are and can be analyzed. And there's this idea of an analytical model in the structural world that is important when you're trying to run it through analysis applications. So what we have here is basically a way to say, using Dynamo, make the thing that looks great from an architectural standpoint and can respond to change, but then at the same time make an analytical model that can be sent out to a variety of analysis packages and is in fact useful for structural engineering workflows. So it's helping different engineering and architecture groups work together more effectively together, and adapting to the specific needs of a project. So this is all work that was developed by some of our users over in Europe to solve specific problems, and then they're teaching that across the world. This was taught at the Revit Technology conference over in Europe this past fall. So, and that's kind of what we want to do. We want to empower you guys to solve the problems you have and ultimately build a community. So that's what we'll talk about a little bit here. So as was mentioned before, this is a little bit different than traditional Autodesk development, where this is an open source project that we're contributing to. It exists out in the world. You can go to dynamobim.org, download this thing. We're contributing to it, and we're building a community around it. So that's a pretty significant thing. So there's a bunch of social media around this on Twitter and Facebook. We'll talk about that a little bit more. And we're using that to help understand what types of problems there are that people want to use, and how can we develop this further, and how can ultimately people help each other. It's another aspect of what we're doing. There's this idea in Dynamo of a package manager where you can create a graph pretty quickly, and not just use it to solve your own problem, but share that with other people. And likewise, if you're trying to solve a new problem, chances are somebody else has probably already solved it, and you could search in this package manager and say, find me something that's going to lay out this type of truss or this curtain panel design, or whatever else, and you'll find something like that. So there's a big community of people that are doing this type of work, and you can leverage that. Another aspect of what we're doing, and we've done this recently in Atlanta back in December, and we do this pretty much around the world, is run these types of workshops where it's kind of hands-on, half-day or day-long thing, get together, and not only learn the software, but try and solve real problems that you have, from your office. So a lot of that's been going on as well. And then there are these things called hackathons that a lot of people are participating in and coming up with great new tools for, literally like over a weekend, making new technologies. So there was just one in New York a couple weeks ago, about 3 or 4 weeks ago, where, leading members of these communities and work at big firms in New York, Thornton Tomasetti and Burrow Happold and Grimshaw and Foster's office and everybody else all come together and try and solve specific problems. And then, as was mentioned, a great resource for this is places like Autodesk University, where we see there was a big pickup last year of about 21 classes focused on Dynamo over the last year, and then big workshops, 250, 300 people working on things. So that's kind of a phenomenon that we're seeing, and we're happy to share that with other people. So let's see. Just in the interest of time, I want to make sure we leave time for live demos. This is just a quick example of some of the plugins that people are building right now. This is one called Dynamo, which is not really developed by Autodesk. It's this company called Case that allows you to read a Rhino file directly and then bring that into Dynamo as a proper NURB surface to be used and sliced and diced using the advanced geometry capabilities in Dynamo before it even gets into Revit. It's kind of one example of that. There's other structural examples connecting to various structural tools. They're out online. This is another one that's being developed by users that connects to an engineering application called SAP 2000, which is a pretty common analysis tool. And basically, you have a way to connect Revit and Dynamo to other analytical tools, be it structural or energy analysis is another one that we see people doing a lot. And then after you get into analysis workflows, we see people wanting to get into things like optimization, where you can start to combine the results of different analysis together and find a good result. So lots of advanced work there. So let's see. Let's switch through this. I'll just do this one last video and then cut over to Colin. We see people doing things like fabrication as well. So not just looking at how something is going to perform structurally or from an environment standpoint, but how can we start to streamline a fabrication process or a construction process. This is a company called The Living, David Benjamin and a bunch of people in New York that were doing interesting architectural research last year that resulted in building a building or an outside pavilion at a place called PS1, part of the Museum of Modern Art. Basic idea is laying out bricks along a non-planar surface, and these bricks happen to be made out of a novel way to reuse sort of organic material like straw and mushrooms to basically grow a brick. And what they're trying to do is lay out a brick along the surface following a set of rules so it can be load-bearing on itself with no other supporting structure. And they were using the computer, Dynamo specifically, to solve for what is the right coursing going to be and how can you lay out full bricks and half bricks and third bricks in a way that follows a set of rules, like it has to be load-bearing, has to be fully supported, and lay out on this doubly curved surface so you can build something like this. So this was built in New York this past summer using some of these advanced computational design techniques. So, and then we also like robots inside the company, so there are people out in the world that are using Dynamo to start to connect, drive other types of fabrication, so robotic fabrication techniques, which is pretty interesting to see as well. So that's kind of a quick spin through what we're seeing people use Dynamo for, and like I said, so it's about geometry, but it's also about connecting the dots between different applications and driving information back and forth in many ways that are not that glamorous, but are real problems that if they were more efficient, they would save you time in your process and ultimately provide better service and better value for the design process. So with that, I'm going to switch over to my colleague Colin, and we're going to do a live demo. So let's see, I can probably just do that from here. Colin, you all set?
I'm all set. I'm ready to go when I see the presenter.
All right.
Great. Hopefully you can see my screen.
Yeah,
so what I have here is that you can, yeah. What I have here is just a Revit family that's open a blank generic model, and my job here is going to be partly to show you that though Dynamo is capable of many amazing things, it doesn't necessarily have to be complicated. You can get some pretty, even relatively simple things done very quickly. So this is the starting page when I open up Dynamo from Revit. I'm just going to open up a new file. This is where you build your graph here in this pane. On the left, I have a library of functionality. In this case, you can see that what's being opened here is the geometry library. The build I'm showing you right now is just a preview of what we're about to release in a couple of weeks, although this is also freely available online, and many users are following our daily build process. But this is one of the exciting additions we've had recently, is to be able to bring much more color and icons and things like that to the library. But one of the things I want to show is, for example, how you would create a point, something very simple. So in the geometry library, I'm going to scroll down to point, and I can see I can make a point several different ways. So if I hover over this, I can see that you have this forms a point with an X and a Y. This one here, I'm going to use this one because I can specify Z also. When I choose this, I'm going to have a node in the canvas. So a node is basically a function. It does something. It has the inputs on the left and the output on the right. I'm going to run this graph automatically, and if I just kick it off here, you can see that by default this is going to push this at the origin. So there's what I could do though, however, is I can move this around by giving this different inputs. This has by default, you can see it as 0, 0, 0. I can give it something else. I'm going to look for something called a slider. So this is, the library is very searchable as well, and I'll use a number slider here, and I'll adjust the range from say 0 to maybe 20, and I'll hide that. Pass it into X, and then I can see as I move this, you can see that what happens is it's becoming, you can move this particular point. So this is very basic parameter. This is something that when we talk about computational design or parametric design, that's exactly what this is. It's something that's controllable by you, and the logic is over here, but then these are the parameters that you can control. So right now this is just a point in Dynamo, but we can certainly do something with it in Revit as well. So I'm going to look for the analog for Revit, which is a reference point. And I'm going to create one using a point. So I'm just going to pass in a point in this case, and I'm going to get a reference point as a result. So as soon as I connect this, oh, I think it might not be in the, I think I'm in the wrong context. I'm going to make a line instead. Okay, I'm going to make a second point and make a copy of this. And this will be at the origin. And the algorithm to make a line would be to connect it between 2 points. So I'm going to use a model curve because that's appropriate in this particular Revit family. So in this case, I'll go for a line and say I can make it by connecting a start point and an end point. This, pass this information in, and I have a line. What I can do is I can make a model curve. This, and as soon as I move this off to the side here, you can see I have a model curve that is connected now parametrically to the context in Dynamo. But it's updatable. So if I increase this model curve, for instance, if I increase the size of the line in Dynamo, then it's connected to the element here in Revit. So you can see that it's just a few nodes you can quickly build up some complexity. There are other things you can do as well. You certainly can start to make a series of things. This is where you would get into something that's really more computational. If I make a number range, a number range would be, starting at, I'm going to start at, say, 0. Start at 0. And I'm going to go to, say, 10. And have a step value of 1. And what this is going to do is count from 0 to 10. This has a step value of 1, and I can say I have a series here. But if I pass this, instead of passing a single number in, this is how you can quickly build up complexity. I can pass in several numbers. So I can have several points along the line, like this. And so I'll move that off to the side. So I can have several lines all at once, and now I have controlling multiple model curves in Revit. This is sort of the basic, hello world, how you can, start to control different things like this. What I'll do is just show you another example of how you might use this to control other Revit elements. I'm going to just close this to reassociate it with another Revit project I have open. In fact, I'm going to use this sample file here. This is a sample file that installs with Dynamo. And I have a particular 3-point adaptive component brackets right here. That's a truss-based family. So that means, as I can take one of these things and it's placed and updated geometrically by, the placement of these points. So if I go back here, one of these things is really begging for the ability to control it computationally. So if I open up Dynamo and relate it to this context, I'm just going to open up a file I have already. One thing I'll do here, this is not connected yet. I'll connect this in a second. As soon as I run the graph, you can see that Dynamo remembers the element IDs of what it's selecting. In fact, what it's looking at is, you can see that in the background preview here, there are 3 curves, and they match these model curves. There's one on the top edge of the wall here, one in the middle here, and one on the top edge of this wall. And we're going to use this as the logic to place those trusses, basically bridging that gap. So when I do this, I can use run this again. I can use logic from the geometry library to enforce that these trusses be very, perpendicular, plumb, and also parallel to each other. And like this, and I can have sets of 3 points that I'm going to connect. You can see these 3 points, and I'll use this to place those adaptive components. Like this. And as soon as I connect that in Dynamo here, then it's updated with placing these trusses. Now this is actually parametrically related. So these are proper Revit elements here. If I click on one of these things, it's actually it is not any sort of strange geometry. In fact, this piece of geometry in Revit doesn't know that Dynamo created it. Dynamo is really basically a busy U. It has the same user access that you do, but it can do lots of things more precisely and sort of in an automated fashion. But you can also, with Dynamo, pay attention to how these trusses were placed. So if I want more trusses, for example, or if I want fewer, I can change the graph, and then it will update accordingly in Dynamo. Fewer, for example, this has several inputs. Just the number of trusses was 1. Another input in this particular file was that these curves that this is based off of. So what Dynamo is doing is it's reading information about the project, manipulating the logic inside of Dynamo, and then pushing information back out. So for example, we can set up the relationship that these trusses are connected to the placement of these model curves. But if that changes, so if I change this in Revit, then if Dynamo is on in the background, then Dynamo can also update those instances like that. But it's also more about just placement. The other thing you can do is you can adjust parameters. What I've done is these particular trusses have an instance parameter that I've called T right here, and basically that the 0.5 says place it halfway between place this point of intersection here, halfway between the left side of the truss and the right side of the truss. What I can do with Dynamo is I can update that pretty quickly. So what I can do is just set parameter value by name. This is my list of elements right here, and the parameter value is called T. And instead, I can give it a different value. I can give it, a value, say, a quarter. So it should be, closer to one side than the other, and I can update them all at the same time. But I can also do it, in some sort of computational way. So list.count I can ask how many trusses are there. And this is actually just a shortcut here to making a series. I can go from 0 to 1 and have this number of divisions like this. And I can have all of these elements update independently in some rules-based fashion. Let me show you some things about data manipulation as well. I have another file open here that is, in fact, this will be the Revit sample project that opens with, just find it here. There we go. This is the sample project that opens with, or that is included with Revit. And I'm just going to do something to just pull out information about this and push it to Excel. So I'm going to open up Dynamo from here. So what this is going to do is it's going to, this is an example of a package. This has a slightly different look to it because it's actually, you can click inside of it. So I'm going to double click right here and it can jump inside of this node. And this is an example of functionality that somebody else in spec, a user has made and wrapped up. And so you can use it as is, or you can go inside and edit it as you'd like. But this is an example of something you won't ever have to think of again. Just to show you very quickly where that lives, Matt mentioned it before, it's on the package manager. Once you're in the client, you search directly here from the packages, and this is going to update with all the different packages that are available. There have been slightly over 50,000 downloads now. If you wanted to know something more about, dealing with room data, for instance, you can look up and see more information about these things, who wrote it, how many times it's been downloaded, that kind of thing. You can install it. This is an example of that. This comes from a plugin called Lunchbox. And what I'll do is I'll just this is a file that is not written for this particular Revit project, but I can open this up and use this in a reusable fashion, and I'm going to call it room stuff. I'll stick it on my desktop, and I'll run the file. So what this will do is in the background it will pull out, first of all, the geometric information about the rooms, which might be useful, but also what level they're placed on and the area for the different rooms. This is something that you can start to manipulate in another way or pass between programs. We've got about 20 minutes left, and there's certainly many more questions we can respond to, but I certainly want to make sure we leave time for that.
Yeah, thanks, Colin. So that was a good kind of quick spin through what you can do with Dynamo, both from a geometric standpoint, but also how you can control operations in Revit and do a lot more with Revit itself from a modeling standpoint, and then extracting information from a Revit model to take it out to other places like Excel. So yeah, at this point, we're happy to take questions from the audience. Let's see. I'm not sure with this technology what the right way to do that is, between either opening up the lines or typing in the chat. Any ideas, guys? Todd or Brad?
Hey, sorry, I was on mute. Yeah, for people that have questions, once you go ahead, there is a question pane on the that you can ask questions. I already see about 3 or 4 questions, and so I can just feed those to you guys. And wow, they're rolling in now, so we're going to be busy. So keep funneling those through, and we'll try to answer those. So we got one early on. What about Dynamo? Does it support imperial units?
Yeah, so I can take that one. So Dynamo is interesting in that in the current form, so there's a base unit in Revit, and that when we built Revit, we settled on essentially internally using decimal feet as a unit for that. And that, you don't really have to ever worry about that from a user standpoint. I mean, you see, if you're working in an imperial project, you see feet and inches. If you're working in metric, you see meters and centimeters and millimeters. When we started doing Dynamo, there was an idea of establishing a base unit that was based on meters. So it was a little bit different there. So in the current version of Dynamo, yeah, the you're going to end up, there is a notion of units, and there's a way to handle them. And basically, sometimes you're going to have to convert from feet to meters, or, cast a number as a length or some other unit. That is changing in the current builds of Dynamo, so that it will in fact be unitless, where if you're working in a meter project, great. If you're working in an imperial project, no problem either. And then, it's just not trying to handle units separately from Revit at all. Colin, you want to add anything to that?
I would just add that the implication of Dynamo being unitless means that when it interfaces with Revit, you'll get the number that you see in the user interface in Revit. So if you have 3 degrees, Dynamo will tell you it's 3. If you have 3 feet, Dynamo will tell you it's 3. 3 cubic millimeters will also come out as 3. So that means that Dynamo is effectively working with your project unit setting directly.
Okay, there's another question that was asked earlier on. Are there any non-geometry examples, something that involves other types of parameters?
Sure, yeah. So we've seen examples of even something as trivial as, you have a rated assembly. You've got a wall that's a 1 hour, 2 hour rated wall, and you want to make sure that the doors that are in it, are rated as well. So making sure that properties and parameters are kept in sync between different objects is something that we see people doing a lot in Dynamo, where you're extracting properties from one object and then setting them in another one, just depending on the rules that you want to maintain. I mean, that would be a good example of that. Colin, any other examples you can think of?
There are quite a few. There's, in fact, let me pull up a blog post here that was.
Yeah, actually, just bring up that case. William Wong, a guy from Case in New York, had a pretty good blog post a couple weeks ago that talked about how they're seeing a lot of customers use Dynamo. And like I said before, a lot of it has really not that much to do with geometry. It's about pulling information, rich information, out of the BIM model and or the Revit model, and doing something with it, either taking it to a different tool or putting it back into Revit in a different way.
In this case, this is an example that Case published about three weeks ago of ways that found to use Dynamo. And in this case, they had the restriction in their project that the door family that should be placed, in fact, whether or not it would have a lock, was dependent on the occupancy of the room. So it was a relatively simple script to put together. They can query all the objects in the project and ask, how many desks they contain. And as that changes, you can see on the left now there are 4 desks. There's a lock. On the right, there are only 3 desks, and so that's a different family that's being placed. So it's a relatively it's not terribly complicated to graph to put together, but this is an example of sort of a data project flow that would not be necessarily geometric. Another one, just as long as we're on this blog, another one to point out is that they were using this as an algorithm to basically label rooms. And so you have this, they started with rooms that were 1, 4, 5, 9, 7, fairly arbitrarily labeled. And then they used a model curve that they drew through this. And they used Dynamo scripts to basically start at the beginning of this model curve and then walk along until it ran into new room objects and then renamed them the next number up. And so they said, select this model curve, start at this number, and they put in 100, and basically press run. And then so Dynamo will go through, find all those room objects, and renumber them accordingly. So you can have, add and subtract rooms and have this as one pretty neat end process to be able to run through and update the object properties.
Okay. Kind of what we were talking before. Lunchbox, are there really any good space planning examples?
Yeah, we're seeing people do space planning, using Dynamo. Where if you think about space planning, really at the end of the day, you build up the programmatic needs for a building, in something like Excel, and then what you can do is even before you have the design layout, you can use Dynamo to create a bunch of rooms that are even unplaced that correspond to that Excel document and are kept in sync with it. And then all you got to do is just place those rooms to kind of test fit them in a design. You could take that further and do some kind of space planning example where I don't think we have one off the top of the cuff here, but either using masses or some level of block walls and rooms just to instantiate the right size, and then you can manually move them around. We've also seen people take that further and start to do actual room layout based on computational rules, but it depends on how far you want to go. But even just the basic idea, just having the same information show up from Excel into Dynamo or into Revit through Dynamo is a pretty key thing. And that could be rooms, that could be a furniture list, it could be a sheet list, all that kind of stuff. It's pretty easy to pull in that information.
Cool. All right, we only got about 32 more here. No, I'm just kidding. What other software can work with Dynamo?
So that's a good one. So because this is an open tool, what we've been seeing is a lot of interest in connecting to other software. And that usually happens in two different ways. One is connecting, still running Dynamo on top of Revit, but connecting to different software using these add-ins that we talked about, these packages. A good one of those is this idea of this package called Dynamo, which connects to Rhino basically, and either reads files themselves or can talk to Rhino as a separate application. So that's a case of that. There's another one called Mantis Shrimp, which is a similar type of thing. And we see a lot of connections to analysis tools, which is another aspect of that. So connecting to structural analysis or energy analysis or that type of thing, or an aspect of that, even Excel, like I mentioned before. The other way that we see people using Dynamo is because we built this thing kind of on top of Revit, but we've been actively working on separating the core piece of Dynamo out from the Revit dependencies, so you can basically run Dynamo in a separate way, not as a plugin on top of Revit, and that actually makes it easier to connect to other applications. We have a lot of parties both inside of Autodesk and outside that are using Dynamo because they can just take the source and compile it and then make connections to different applications. So I showed some of the structural examples earlier of having Dynamo work on top of things like robot structural analysis, which is a different application. It's not based on Revit at all. So you can see the potential for more of those happening in the future. We also have seen other people. There's a guy, Frank Freilich, from the Beck Group, that to support their own needs around design to fabrication, self-performing work, they wrote a connector between Dynamo and Inventor, where they can basically drive Inventor geometry using Dynamo and saving that same recipe, that same script, to create the same thing in Revit and the same thing in Inventor. So they can be assured that it's the same thing will be fabricated that was designed. So those type of workflows we see pretty common.
Okay. Any simulation capabilities with Dynamo?
Yep. So lots of simulation. So we see a lot of energy analysis and other types of analysis capabilities, and that's not just about pulling information back in and seeing it in a number format. That can be showing it graphically inside of either Dynamo or inside of Revit itself. So in the case that Colin's doing here, laying out basically some curvy geometry and building a space frame for it or a set of curved trusses, you can analyze those and start to look at the reactions on them, what are the various stresses and strains, and start to do sizing on that and show that graphically. So that type of simulation we see pretty common, and then there's other types of simulation that people are building as well. There's a company in New York that taught a class at AU about how to create essentially their own plugin, their own package using Dynamo, and they had a really specific need of, hey, this company called Weidlinger, they do blast analysis, so they do structural engineering, but then they also say, in the case of a big explosion, what would happen? How would the building perform against that type of impact load? So they were able to take their custom code and make a Dynamo plugin or your add-in or package for it really easily to support a specific type of simulation.
All right, great. This isn't a question, but I want to replace one family with another using Dynamo and Excel. Maybe skip that one.
Yeah.
Does that make sense to you guys?
Yeah, and it's sort of a statement, but yeah, Colin, you want to talk to that?
Yeah, you absolutely can. In fact, the process for that would be, when you have the family listed in Excel, it's a text string, and so you can use Dynamo to read that text string, find the associated family that has the same name, and then you could choose to delete certain instances of other families and replace it with that particular family. Exactly what algorithm you use is really up to you. One thing we see people do sometimes is, if they have, for example, they have, a set of columns that they need to place, and then there are, it's one family, but then there's several different types. And so you can go through and if you have the information in an Excel file, maybe you got from your structural engineer, then you can go through and place the particular or type, or even a separate family at the place that's indicated, and give the length that's needed and associated with the correct level. Those are all things that are exposed right out of the box.
Okay, cool. How would Dynamo be used to solve the room separation line issue, where room bounding could be solved for exterior edge of walls in combination with interior center lines and any combination that may occur?
Yeah, I'm reading that one right now too. Let's see. Okay, yeah, so this is, if I'm interpreting this correctly, there are certain rules like BOMA area analysis rules, which have to do with, if you want to build a room that's 100 square feet, where you measure to depends on the condition of that wall. Like, so exterior walls are typically measured from the face of interior, but interior partitions can be measured to the center of the wall, or depending on the rule that you follow. Let's see. So we have, inside of Revit, there's a bunch of rules for that, for different types of area layout already, but they're kind of hard-coded. So if you wanted to build your own rules like that, there are ways to do that. You would need to know the thickness of the walls. You would need to control not just the location line of the wall, but the I can't remember the name of the parameter, but the placement position, basically, like, is the wall centered on the location line, or is it offset to face of interior, face of exterior? But those are all controllable via the API. I don't know if they're exposed in Dynamo proper, but if they're not, you can expose them using Python script or some other custom script. And then you basically have to figure out, okay, as you lay out the thing, is the area the right size? And if not, change the wall position until it is. So you could do it. It's not trivial. It's not a small amount of work, but it's definitely possible.
And just some clarification on the simulation question. It was kind of for highway transportation or baggage handling systems. So that's going back to the question. Yeah, just any simulation capability. So I guess simulation within a building.
Oh yeah, okay. So like a larger, like a system, like a baggage handling system or something else that has some dynamic aspect to it. Yeah, if you have the operational characteristics of it, if it says, okay, it can process whatever, 200 bags every 10 minutes or something like that. You can build that into the model and say, okay, how many bags are in this particular area in a certain time, and how quickly can they be processed, and all that kind of stuff. It's just kind of a logical thing. You could actually even start to simulate this by changing the position of bags. If you wanted to actually physically see them moving down the conveyor belt or something, we've seen people do that as well, start to do animation of objects in Revit using Dynamo. There's actually a package called Dynamo that I don't know if they've actually, this guy Havard created it during AU, this hackathon, where they basically animated the building based on changing on different parameters and taking screenshots of it and making a little movie out of it. So yeah, depending on what you mean by simulation there, if it's just like, yes, it will process this much amount versus showing it, you could do both of those. Yeah, so Colin's kind of seeing this, like, so you can see like these are, a set of circles or whatever, just kind of going along a certain spline path. If you imagine taking a screenshot at each one of those number slider positions, if you animated those screenshots together, strung them together in a movie, you'd see those circles sliding along the curve. And that's all possible, both from the Revit view or from the Dynamo view.
Okay. Are there any heating and cooling load modules already available in the Dynamo Package Manager? Could new space types be added using Dynamo for building load analysis?
That's a good question. I don't know of any specific heating and cooling load packages right now. I do know that inside of Revit MEP there are more and more capabilities that are being added there, and to the degree that they're exposed via the API, the Revit API, then you could get them via Dynamo and start to control them as well. And then for space types, usually you're kind of limited on the number, the types of the categorization of objects in Revit. If it is something that you can add manually by changing the name of something in the Revit UI, then certainly Dynamo can add those for you as well. But if it's a hard-coded one, like if you have a fixed list in a drop-down, typically it's not possible for an API plugin like Dynamo to add more either.
Okay. Got a couple more here popping in. Those room notes from Grimshaw and Lunchbox, are they available to all or specialty libraries?
Yeah, pretty much everything that Colin has here, these are all publicly available. This is just an active web service that just exists out on the internet that if you're running Dynamo and you have enough network permissions in your company, you can get out to.
Okay. Is there a certain place they can search for those?
Yeah, so you can do that. What Colin's showing now is inside the application itself, just this package search, or you can do it. We have a separate website called dynamopackages.com that you can go to. You can actually access it, yeah, from the Dynamo BIM website as well. So you can kind of view it, yeah. So discover the packages. It just launches like a different little website. And this is just a way to see them all, and you can see other stats, like in this case, how many people have downloaded them and all that kind of thing. So it is kind of like a meritocracy, like the most popular ones or the ones that are most useful kind of rise to the top. And we see certain ones that come online are really popular and people download them and use them a lot. So.
Right. Great. We're going back to some previous questions. Can you use Dynamo for space planning?
Yeah, so sure thing. So the same thing I mentioned before is that if you have a building program in whatever form, you could write it down on a napkin, you could put it in a Word document, you could put it in Excel. If you write those things down and Revit doesn't really know about them, you can read that information into Revit using Dynamo, just to kind of using that Excel link that Colin showed before, or just reading a text file or whatever, and then what you can do is basically create rooms that are simply haven't been placed yet. They're sort of able to be placed, and they have the right information, like the room name and number and description and all that, and then place them manually inside of the application. And then you can get into more complicated workflows as well, where you're physically laying out where the room should be as well, either at a conceptual level, kind of with a bubble diagram type thing, or in a more detailed model where you might have walls or area separation lines already set. So, and then we see people doing things like kind of fitness, like sort of sort of test fit idea. Like, okay, if the program requires for 25,000 square feet, but in this particular layout you can only hit 22,500 square feet, just because of the limitations, then you can see like where you're over or under for certain rooms that way.
Great. All right, we got one last question. This is more of a statement. I have old families in a project. I need to update them with new families named differently, of course. I can map old to new in Excel. Just need the inserting point and rotation angle extracted.
Yeah, I mean that's basically. I think that's more of a statement, but yeah, I mean that's possible today. Yeah, basically like swapping stuff out. I mean it's kind of like sort of find and replace, in other tools. See people do that a lot.
Okay. All right. Well, I think anybody have any other final questions before we close the lines? All right. I think that's it.
Well, thanks everybody. Really appreciate the time, and hopefully for those of you in the Atlanta area, you can get home safely today and don't have to deal with ice and snow and all that.
Okay, great. And yeah, I want to thank you guys for helping us out with this webinar. We are going to, this webinar was recorded and it will be posted to our Live Lab Learning channel via YouTube, and we'll send an email probably tomorrow, maybe later today, with it recorded and a link so you guys can access it and share with your teams internally. But I just want to thank everybody for taking the time out of this day and sticking it out with the impending weather, but we appreciate it. We appreciate Autodesk taking the time as well to help educate some of the folks down here in the Southeast on Dynamo and its many uses. So thank you guys. Thanks everybody.
Thank you.